Welcome to the deep dive. So imagine you're a developer, maybe like, let's call her Sarah. Her startup's website, it just exploded, right? Started simple, one app. Now she's got like a Node.js front end, a Python thing for payments, maybe a Java API managing inventory.
Yeah, that sounds familiar. All running on different internal ports, probably.
Exactly. And her big challenge is, how does she make all that look like just one site, www.hercompany.com, to the outside world? Keep it secure, route the traffic right, without poking holes everywhere.
That's a super common problem today. And honestly, it's precisely what Apache HTTP Server can solve when you use it as a reverse proxy.
Right.
Managing all those different apps or microservices, plus keeping them safe. It's a constant balancing act.
Totally. You need to protect your stuff online, but figuring out the how,
yeah,
it can get overwhelming fast.
Yeah, it really can.
So that's our focus for this deep dive. We want to cut through that complexity, give you a kind of shortcut to understanding two really key things. Yep. First, how to actually set up Apache to route traffic cleanly to all those different backend apps. And second, how to seriously boost your security, protect your users by adding these important HTTP security headers.
And we're digging into a technical guide here, one that's full of practical examples, actual configurations.
Right.
So we're not just talking theory. We can get into the why behind the commands, not just the what. Hopefully uncover some, aha moments.
Perfect. Okay, let's start with the basics then. A reverse proxy. Sounds kind of technical, maybe a bit intimidating.
It can sound that way, but yeah, you can think of it like the ultimate traffic director for your website. Or maybe a bouncer and receptionist rolled into one.
Oh, okay. I like that. How does it work conceptually?
Well, it sits right at the front, facing the public internet. It grabs all the incoming requests from users' browsers.
Okay.
And then it intelligently sends them or proxies them to the right backend server running internally. So you type https.yourdomain.com. That request hits Apache first. Apache looks at it and says, this needs to go to the Node app running on, say, localhost 0.3000, or maybe this API request goes to the Python service on port 8000.
So it's like a middleman, hiding the messy internal stuff.
Exactly. It shields your internal network structure. That's a big security win right there. Plus, it simplifies things immensely from the outside perspective.
Makes sense. So it's this central point before we even get into how to tell it where to send stuff. What needs to be in place on the Apache server itself? Any prerequisites?
Oh, definitely. You obviously need Apache installed, but then you absolutely need certain modules enabled.
Modules.
Yeah, think of them like plugins for Apache. For reverse proxying, the main ones are modproxy and modproxy ETP. Those handle the basic forwarding.
Okay, modproxy and modproxy TTP.
And then crucially, you also need mod headers. That's the one that lets you add those security headers we mentioned.
Gotcha. And you enable these with commands, right? Like a to and mod?
Exactly. Sudo to and mod proxy TTP headers. That command isn't just fluff. It actually creates symbolic links to tell Apache, hey, load these features.
Okay.
And then super important, you have to tell Apache to actually use them. Usually with sudo systemtl restart Apache2 or reload Apache2. Reload is often better as it doesn't drop connections.
Right. So you flip the switches, then tell Apache to reread its instructions.
Yeah.
Understood. So modules enabled, Apache refreshed. Now, how do we tell it where to direct traffic? How we translate traffic director into code?
Okay, yeah. This usually happens inside what's called a virtual host configuration file. Typically, you'll find these in Apache2 sites available. Maybe a file named something like yourdomain.com.
Right. Standard place for site configs.
Inside that file, you define things like your server name, yourdomain.com, and maybe server alias for www.yourdomain.com.
Pretty standard stuff.
And then job number one for any modern site, .force HTTPS. The source guide shows a really simple way. For the port 80 virtual host, you just put redirect permanent https.yourdomain.com. Boom, all HTTP traffic gets sent to the secure version.
It's nice and clean.
Yeah.
Okay, so that's the HTTPS redirect sorted. Now for the actual proxying rules, how does Apache know, say, requests for the main site go to the Node app, but requests for API go somewhere else?
That's where the ProxyPass directive comes in. It's really the core of it.
Okay.
There are a couple of key parts. First, proxy preserve host on. This is important. It tells Apache to send the original host header from the user's browser through to the backend app.
Why does that matter?
Well, many backend apps rely on that header to know how to generate URLs or identify themselves. If you don't preserve it, the backend might get confused, thinking the request is for localhost or something.
Okay, so proxy preserve host on.
Then the main directives, ProxyPass and ProxyPassReverse. So ProxyPass http.localhost.300 that tells Apache. Any request starting with, so basically everything, forward it to the server running on localhost port 3000.
That's the Node app in our example.
Right, but you can get more specific. You could add another line before that one. ProxyPass AP http.localhost.888.
So order matters.
Yes. Apache matches the most specific path first. So APWA requests go to port 8080, maybe your Java API. Everything else falls through to the rule and goes to port 3000.
Clever. So you can carve up your URL space and send bits to different internal services. What about ProxyPassReverse? You mentioned that too.
Yes. ProxyPassReverse is super important and easy to forget. Let's say your backend app sends a redirect, like go to login.
Okay.
If that redirect comes back to the user's browser as http.localhost.3000 login, their browser isn't going to be able to reach localhost.3000 login.
Right, that's internal.
ProxyPassReverse http.localhost.3000 fixes that. It intercepts those redirect headers coming back from the backend and rewrites them to use your public domain, like https.yourdomain.com/login.
So it cleans up the responses too. I can see how forgetting that would cause weird problems.
Oh, it does. I remember debugging a site once. Users clicking login, getting bounced to an internal IP, connection refused. Took ages to spot the missing ProxyPassReverse. It's a small line, big impact.
Good tip. Okay, so that covers the routing, getting requests to the right place, and making sure responses come back correctly. Now let's shift gears to the security headers. Why are these so vital?
Right, the headers. They are absolutely critical because they provide instructions to the user's browser on how to handle your content safely. It's a client-side defense layer.
Client-side, meaning it works in the user's browser.
Exactly. Take X-frame options. Setting it to SAM origin, like header always set X-frame options, SAM origin.
Oh, way.
That tells the browser, do not allow this page to be displayed in a frame unless the framing site is the same origin as this page. It's the primary defense against clickjacking.
Clickjacking. That's the invisible frame trick, right?
Yeah, where an attacker puts your site in a hidden iframe on their malicious page and tricks users into clicking things on your site like a delete account button while thinking they're clicking something else. X-frame options just stops that cold for most browsers.
Makes sense. Very targeted defense. What about X-content type options? No-sniff. What sniffing is it stopping?
MIME type sniffing. So browsers sometimes try to be clever. If a server says, this is an image, but the content looks like JavaScript,
Oh, yeah.
the browser might say, I think this is actually script, and run it. That's dangerous if an attacker manages to upload a malicious file disguised as something harmless. No-sniff tells the browser, don't guess. Stick to the declared content type. Simple, but effective.
Got it. Stops the browser from second-guessing file types in a potentially harmful way. Now, XXSS protection. The source mentioned it's mainly for older browsers. Is it still worth including?
That's a good question. XXSS Protection 1 mode block tries to enable a built-in cross-site scripting filter that used to be common in browsers like IE and older Chrome Safari.
Used to be?
Yeah, modern browsers have largely deprecated it because, frankly, content security policy is way better and more reliable. Sometimes XXSS Protection could even introduce vulnerabilities itself.
Oh, really?
Yeah. But some people still include it as a sort of fallback defense for users on ancient browsers. The real heavy hitter nowadays, though, is content security policy.
Okay, let's talk about that one. CSP. It sounds powerful.
It really is. It's like setting up a firewall inside the user's browser specifically for your page. A basic policy like header always set content security policy default self.
What does self mean there?
It means, by default, the browser should only load resources, scripts, images, style sheets, fonts, everything from the exact same origin, domain, protocol, port as the main page itself.
Wow. So no loading scripts from random third-party domains.
Exactly, unless you explicitly allow them in the policy. This massively reduces the attack surface for cross-site scripting, XSS, because even if an attacker injects a malicious script SSR tag pointing elsewhere, CSP tells the browser, nope, not allowed.
That sounds incredibly useful, but maybe tricky to configure if you do use third-party assets.
It absolutely requires careful configuration. You need to list all the legitimate sources you use, but it's one of the most effective defenses we have against XSS today.
Okay, next up, refer policy. What's that controlling? Sounds like privacy related.
It is. It controls how much information about the referring page, the page the user came from, is sent when they navigate away from your site, like clicking an external link.
Ah,
A setting like strict origin when cross-origin is often a good balance. It means if the user stays on your site, the full referring URL is sent, which is useful for your own analytics.
right.
But if they navigate to a different site, cross-origin, only the basic origin, like https.yourdomain.com, is sent, not the full specific path they were on. Protects user privacy a bit better.
Makes sense. Protects the specifics of where they were on your site. Okay, last one on the list. Strict Transport Security, or HSTS. This one sounds important.
Oh, it's huge. Header always set strict transport security, max age, 315.36000, includes subdomains, preload is a very strong statement.
What's it telling the browser?
It's saying, for the next year, max age is in seconds, 315.36000 is 1 year. Never connect to this domain or any of its subdomains, include subdomains, using insecure HTTP. Only ever use HTTPS.
Wow, never. Even if the user types HTTP.
Even then. The browser, once it sees this header, will automatically upgrade the connection to HTTPS before sending the request. It helps prevent attacks like SSL stripping, where someone tries to downgrade the connection.
And what's the preload part?
Preload is a step further. It signals that you intend to get your domain included in a list built into major browsers. If your domain is on the HSTS preload list, the browser knows to only use HTTPS for it even on the very first visit, before it's even seen the header from your server.
That sounds incredibly secure, but also kind of permanent.
What if something goes wrong with your HTTPS setup?
That is the crucial insight, exactly. HSTS is a commitment. Once a browser learns this policy for your site, it will not let users connect over HTTP for the entire max age. If your certificate expires and you don't renew it, or if you need to temporarily serve something over HTTP, users who have visited before might find your site completely inaccessible.
Oof. So you need to be sure you're maintaining HTTPS long-term before enabling HSTS, especially preload. Absolutely. It's a powerful tool, but wield it carefully. Plan for certificate renewals way ahead of time.
Excellent point. Okay, so we've got our Apache config file, maybe yourdomain.conf, with ProxyPass rules and all these header set directives for security. How do we make Apache actually use this new configuration?
Right, you've edited the file in Apache2 sites available. First, you need to enable it. That's usually sudo a inset yourdomain.conf. This creates a symbolic link in the site's enabled directory.
Okay, enable the site.
Then you need Apache to reread its configuration. Sudo system reload Apache2 is generally the best way. It applies the changes gracefully without a full server restart so you don't drop active connections.
Reload, not restart. Good distinction.
And as the source material really emphasizes, and we've touched on, always use HTTPS. There's really no excuse not to anymore. Let's Encrypt via certbot makes getting free, trusted SSL TLS certificates incredibly easy.
Absolutely. Free certs changed the game there. So you've done all this, configured the proxy, added the headers, enabled a site, reloaded Apache. How do you know it's working? How do you check your work?
Great question. For the security headers specifically, there are fantastic online tools. securityheaders.com is a popular one.
How does it work?
You just enter your domain name, and it connects to your site, checks the HTTP headers it receives, and gives you a grade and a detailed report on which headers are present, which are missing, and if the values are set correctly, it's an instant sanity check.
Nice. That sounds super useful.
Yeah, it really is. And remember, particularly for content security policy, you need to test thoroughly. A default policy might be too strict and break parts of your site, or too loose and not provide much protection. You have to tailor it carefully to the actual scripts, styles, images, etc. that your front end needs to load.
Right, not just copy-paste a generic policy. Okay, so let's try and recap this deep dive. We've seen how Apache HTTP server can be configured as this really effective reverse proxy.
Yeah, acting as that central point, taking requests like for https.yourdomain.com and smartly routing them to internal backends, like an app on http.localhost.300.
Or even routing different paths, like HTTP to totally separate internal services.
Exactly, using ProxyPass and remembering that crucial ProxyPassReverse.
And then we layered on the security, looking at how essential these HTTP security headers are. They're not optional extras, really.
Definitely not. Headers like X-frame options stopping clickjacking, X-content type options preventing MIE sniffing, the powerful content security policy fighting XSS, and strict transport security locking down HTTPS. They all work together in the browser to protect your users.
Understanding how to actually set this up, enabling the right modules like mod proxy and mod headers, using a to site to activate your config, system title reload to apply it, this really gives you the power to build much safer web applications.
Absolutely. And reinforcing those best practices. Always use HTTPS, get those free certs with Let's Encrypt and CertBot, and regularly test your headers using tools like securityheaders.com. Don't just set and forget.
Right. Which brings us to a final thought. We talked about how crucial it is to tailor your content security policy specifically to your site's assets, and also the need to audit your proxy setup regularly to make sure you haven't accidentally created an open proxy vulnerability.
Constant vigilance.
So if that level of ongoing attention tailoring, auditing, adapting is necessary today, what does that really tell you about the nature of web security? Is it ever really done? Or is it more about a continuous responsibility to understand, implement, and evolve these measures as the digital landscape itself keeps changing?